let's look at how we did this cross-country course problem with 3 legs. We got a quick recap at the end of class, but let me go through it one more time. It won't take too long. We had 2 ways of doing the problem, and the original way people came up with was the most successful way is to use law of cosines on this triangle. But it's kind of annoying. You have to do some angle chasing first, and then you have to use law of cosines, and then you have to do some more angle chasing to get back to the data that you wanted. Not too much fun. So instead, let's focus on the solution we saw at the end of class, which is really a much more coordinate-based solution. And really what it's doing is using vectors, which we'll introduce very soon. So the idea was to look at how far east or west, which would be negative, and north or south, which would be negative, each leg goes. Okay? Or in other words, using x and y terminology, how much does x change in each leg, positive or negative, and how much does y change? Okay, so another way to say that is I've drawn in these dotted lines here. We're really kind of putting right triangles everywhere. We're taking this segment and we're saying, you know what, I'd love to analyze that using this right triangle to relate it to coordinates. And this leg here of this right triangle is going to be how far this path, this journey, this part of the cross-country course goes to the east. And then this right triangle here, this leg here is going to be how far does this one go to the east. And the key to the whole problem is that once you've got those, I can figure out where this point is relative to home base by just adding how much did the first leg take me east and then how much did the second leg take me east. Similarly, I can figure out where this is relative to home base in terms of north and south by saying, okay, this one took me this much north, and then it looks like I might have to subtract or do something weird with this guy. But as long as I count this as a negative number, how much this leg took me north, I'm going to say it took me north by a negative amount. You just add in that much positive north and then add in the negative north, and you get how much north did I go from A to C. Well, it turns out to be negative in the picture, but that's okay. It's just automatically in the numbers. So let's look at the numbers real quick. So the first stage was convert to x and y. We had magnitude and direction information. We had the information, I have it right here, that this is 2 kilometers and this angle right in here was 60. That's the 60 right there. Okay. And so the first leg goes east by 2 cosine 60. That's, if that looks like a polar coordinate conversion, polar to Cartesian coordinate conversion, it should. Okay, which turns out to, oh, not 60, I'm sorry, this is a 45. Very sorry, that's a 45. I'm getting confused. 2 cosine 45, which is root 2, or just 1.414, let's say. It turns out decimal's best for this. And it goes north by 2 sine 45 degrees, which happens to be the same number. Okay. And I'll put the units in here. That's probably a good idea. Kilometers. They're all kilometers. Okay. So, in other words, that's the x and y coordinates at this point. But you don't want to get too wedded to that idea that these calculations are all coordinates of points, because the next one is really this distance we're going to calculate, and this distance. We're going to say how much relative to B, how far east is C, and how far relative to B, how far north is C. And so it's not called a coordinate, it's going to be called a component of a vector. How much does this motion move me in the x or y direction? So it's not quite the same as a coordinate. Second leg, we're going to have, it goes east, east by 3 cosine minus 60. The minus, remember, is because this angle is in the clockwise direction. So even though Sketchpad measures it as a plus 60, it's really should be put in as a minus. As long as you're really religiously careful about the signs, you don't have to do any finicky fiddling with quadrants here. That's a really nice thing about this method. And that is going to be, it's still a simple number, it's 1.5. I don't need that, okay, kilometers. And we go north by 3 sine of minus 60. Here's where that minus sign really does affect us. It automatically gives us a negative number, and it turns out to be negative 3/2 root 3, and let's have it compute that. Okay, it gives us some weird characters here. Actually, let me hide all those. Oops. Okay. So, negative 2.6. Okay, so let me make a little table for here, for this. Let's see. Let me make a little table with 3 rows and just 2 columns. Okay. So, actually, now let me insert a column. Okay. Leg 1 and leg 2. How much does it go, east? And so that's really the x coordinates. The change in the x coordinate, and then the north is in y. Okay. So leg 1, I went east by 1.414. Here, I went north 1.414. Here, I went east by 1.5 and north by 2.591. Okay, but negative. Okay, well, now what do I do? To get this amount, to figure out, in other words, to figure out the coordinates of C, I can just add these together. That's the great thing. And so let me just actually insert one more row at the end here. Okay. So the shortcut, one way to think about it is if I want to go directly from home base to the end of the second leg and just shortcut this thing, it's just going to be the sum. 2.914, and I don't know if I trust myself to do that directly. Let's see. 1.414 minus 2.5981. That's going to be minus 1.1841. And so that gives me the coordinates of this point. From there, it's really pretty easy. Okay, so the first stage was convert to xy, and then here's the second stage of the problem, second step maybe, is just add the columns. Once we've got how much motion there is east in each individual leg, the shortcut is just adding the columns. Okay. Now, here's a tricky thing. The problem was actually to go backwards. It was actually, what do I need to do to go from C to A? Okay, well, that's easy. That means I'm going to move, I don't need that. I'm just going to move minus 2.914 in the east. In other words, I'm going to move west. And positive 1.1841 north. So I really am moving west and north. Okay, so now the third stage, what was being asked for was the magnitude and direction. I've got this much east motion, this much north motion. I've just really got to convert that to a magnitude and direction. And that's exactly a Cartesian or rectangular to polar conversion. The magnitude, that's just going to be the square root of 2.914 squared plus 1.1841 squared. We'll have it do that for us. And that's what we got. And the direction, well, let's see. We just need tan theta is equal to the y over x minus 1.1841 over 2.914. Or in other words, theta, let's see. Theta equals, is it the arctan? Well, maybe, maybe not. Let's see what it gives us. Now it's going to do it in radians. Okay. But let's see. A negative radian. Oh, that's not right, because that would be down in this quadrant. We want to be in the second quadrant, because it's this angle here that we want. It's really supposed to be 158 degrees. So we need to do a couple things. First, we're just going to convert it. Now, if your calculator is set for degrees, you don't have to do this step. times minus 0.38597. Compute that numerically. Okay, minus 22 degrees. That would be the angle if you were going away. And that's the annoying thing about converting to polar. You often have to add 180. But if we add 180, then finally we're done. 157.89, which is what the sketchpad is telling us. Okay. So this might seem like a lot of work, but the key thing is that this scales really, really well. If you had a cross-country course with 4, 5, 6, 10, 100 legs, this step is just convert, convert, convert everything. This step, you just add everything up, add the columns once you get it converted, and then you have to do one more conversion back. And we're going to do a 5-leg version soon to finish this intro to these kinds of methods. Secretly, and then we're talking about the terminology. Secretly, we're really doing vectors here, but we'll put the terminology in after we get the idea.